Hi, I'm Bob Tabor with LearnVisualStudio.net. As I said at the outset of this series, half of the battle to learning how to develop software is learning the Visual Basic syntax. The other half of the battle is learning how to utilize the .NET Framework class library. Now, when referring to the Framework class library, I emphasized in the past that it has another name that it's known by. It's also known by the name Base Class Library, which is actually interesting because, as you'll learn in this lesson, it adequately describes what the library actually is. It is a library of base classes and derived classes, and we'll learn about that in just a moment here. To set up this lesson, I've created a before snapshot that you'll want to download from wherever you're streaming this video or downloaded this video from. In this case, I have the folder on my desktop, and you should be able to find a before folder, and it should contain an understanding inheritance subfolder. I'm going to right click and copy this, and now I'm going to go to that place on my hard drive where Visual Studio saves projects. Now, whatever I have here might be different from what you have depending on your edition and version of Visual Studio. In my case, it's saved in the Visual Studio 2010 folder under projects. But again, this might be different for you, so use whatever folder your version and edition of Visual Studio is using to save your projects in. I'm going to double click projects and then right click in some empty area here and paste in our Understanding Inheritance project. I'm going to double click the folder and then double click on the solution file to open it up in my version of Visual Studio. Okay, so let's take a quick tour of the project. First of all, you can see that I have two files, car.vb and module1.vb. Car.vb is a class. It contains properties of a car that you're already familiar with if you've been following along. Also, it has a method called printMe, which merely writes to the console window some properties of a given instance of the car, as well as just a little note about where this line was printed from. It was printed from the car.printMe method. If we take a look at the module1.vb submain, you can see, first of all, we're creating an instance of the car class called myCar. Here we're populating the properties of this instance of our class, and then we're calling the printMe method that we just looked at a moment ago. In line number 16, we're calling a helper method called SumMethod. SumMethod takes as an input parameter a type of car. Now, as a side note, notice that I'm using the word car as the name of the input parameter as well as the class, the input data type. And that's legal in Visual Basic. You'll see this used by some developers in code examples that you'll find online and in books. And it's a common convention. Visual Basic is able to sort it out. Notice that it is able to, as we hover over, realize that we're talking about a class given this use of the word car and the name of the parameter as this use of the name car. Okay, so here we're merely just printing out some details about the car, and we want to also take note about where this is being called from. If I run the application, it merely prints two lines to our console window, one from printMe and one from SumMethod. Great. Okay, and this is all well and good, but let's suppose for a moment that our car class, while it's great for cars, needs to be expanded in order to work with trucks. Now, in some ways, trucks and cars are exactly the same, and in some ways, they're a little bit different. So what are my options if I wanted to implement a truck class? Well, I suppose what I could do is just right-click, create a new class, add new class, call it truck.vb, and then go and copy all of this code out of the body of the car class and paste it into truck. Now, there are a couple of issues with that. First of all, it violates one of our rules. Rules that have been developed over time by developers who have felt the pain of making all the mistakes so that you don't have to. And one of those rules is to never write the same code twice. It's not just a matter of having twice as much code to maintain, although that certainly would be the case. But if we copy and paste code from one class into another, and that code happens to be buggy, what if we find that bug, now we have to fix it in multiple places, or we forget about it and we don't fix it in multiple places? Well, that certainly creates an issue for us. Or we could just go ahead and retype in all the code by hand, but what if we were inconsistent in our application of the business rules? And so now the logic itself needs to be fixed in 2 or more places. If we really need to implement something that's similar to a car but is slightly different, then we might want to use a different mechanism. Ideally, we can merely borrow the things about a car that make sense to borrow. We can overwrite the parts that don't make sense for our truck, and then add parts about a truck that cars really don't need, say like a towing capacity or bed size. And so we can do this by creating a class called truck and then making it inherit from car. And then we can specialize the truck class by adding properties and methods to it. To do this, what I'm going to do is right-click on our project in the Solution Explorer and select Add Class. I'm going to make sure that class is selected. It should be in the Add New Item dialog, and I'm going to call this truck.vb. Click Add, and all I'm going to do here is go to the end of the word truck, hit the Enter key on my keyboard, and then type in inherits car. Now that's all I'm going to do to start off with. I'm going to go to the module1.vb, make a little room for myself here, and I'm going to dim my truck as new truck. So with my truck, I'm going to do dot, and notice that it gives me all of the properties that were defined in car. All I did have to do was inherit from car to get those, and I don't have to type any more code. So make equals Ford, model equals F250, year will be 2006, and color will equal white. All right, and now what I can do is my truck dot print me, and I can also call some method and pass in my truck. And let's go ahead and run the application and make sure this works, and indeed it does. So we were able to inherit all the properties and methods of car. Additionally, since truck is a subclass or a derived class or a child class of car, we're able to use it anywhere car is used. Pretty cool. Now there are a bunch of benefits to using inheritance. The most obvious is that you can save some code, but it goes much deeper than that. Anywhere a car would work, like as we saw just a moment ago, as an input parameter to a method, truck will now work as well. So in this situation, the car class is referred to as the base class, and truck is referred to as the derived class. Also, depending on who you talk to, car class is referred to as the parent class, and truck class is referred to as the child class. Or depending on who you talk to, car class is called the superclass, and truck is called the subclass. Okay, so there are a lot of different ways to talk about these, different terminology we can use, and depending on what book you read or article, they're all the same idea. It's just that over the years, several different authors have used different ways to express this relationship between the classes. But our purpose in this lesson is to talk about how the .NET Framework class library is just one massive collection of base and derived classes. Why do you suppose Microsoft chose to architect the framework in this way? Well, because it creates this flexible way of working with classes in the framework. So one example, and there are many, many examples that we could choose from, but just picking one, let's take a look at a file stream class. If you take a look at this URL, which should be printed to screen right now, this is from MSDN. This will become a great resource as you try to learn more about the framework class library and techniques for utilizing the classes inside of it. So I'm looking at the file stream class. It's a cousin to the stream reader that we saw previously in lesson 11 when we created the read text file while project. Okay, so the MSDN help will tell us basically the purpose for this class, which is to allow read and write operations on a stream of bytes that are essentially saved in a file. Now the MSDN help shows us that file stream right here, it derives from System.io.stream. Okay, I'm looking at this in a section that's labeled Inheritance Hierarchy. It shows the relationship of this class to its base classes. So you can see that it goes back several generations, if you will. If I click on System.io.stream, and then I click on this little more link below it, this will show you all the classes that derive from or are children of the System.io.stream class. So we can see our file stream class right here, and it has a number of siblings, and each of these derive from the same base class, System.io.stream. In other words, they all work with streams of bytes. Even though how they work with those bytes might be dramatically different. Some work with streams of bytes in database data, some with zipped files, some with bytes streamed over the internet, and more. Since each of these classes work with stream, they can borrow from the base implementation of stream and be used in a similar way. So from a practical standpoint, once you learn about how streams work generally, you can expect similar behavior as a user of the various stream classes. Instead of just memorizing the specifics about each class, you can kind of fumble your way around by associating things that you know about stream classes already to a new usage of stream-based classes. Furthermore, you could write code, let's say a method, for example, that allows a stream to be passed into the method. Now your method is extremely flexible. It can work with any stream class that inherits from System.io.stream, and that's exactly why Microsoft chose to use this model when designing their framework. Because many times you'll see that you can pass in a base class, which is a clue to you that you could pass in any of the derived classes and get the same functionality that you're looking for. So it makes it ultimately flexible, okay? So I don't expect you to go out and use this in your own code to develop some grandiose framework just yet, maybe someday. But the bigger idea here is learning how the framework is structured so that you can fumble your way through it and figure out how things work. And so inheritance is a big piece of that. All right, so let's move on. Let's actually shut that down. All right, so let's go back to our truck.vb class or our car.vb, and suppose that there's something about printme that just doesn't work quite right for our truck class. Maybe we need a slightly different implementation. Maybe, for example, our truck needs to display not only the make and the model, but also the towing capacity. Well, first of all, what we need to do is implement a towing capacity property to specialize this class. So let's go public property towing capacity as integer, and then let's override our printme method. So let's start off by doing this. Public sub printme, and this will not work, I know that. We're going to walk through this little by little. Console.writeLine, and here we'll just do okay, so what I'm attempting to do is to cover up, or rather override, the default implementation of the printme method. Now, when I do this, I get a little green squiggly line that says printme shadows an overloadable member declared in the base class. But if you want to overload the base method, this method must be declared overloads. So that gives me a little bit of a hint as to what to do. What I actually want to do is use the overrides name, and when I do that, this now turns to blue, and you can see that it cannot override public sub printme because it's not declared as overridable. So we need to go back into the car class and label this as overridable. All right, and so now when we do that, we make that change, Everything seems to work. Let's go ahead and rerun our application. And one other change I'll want to make here is in my truck, I've added the towing capacity. So let's go ahead and set that. And we'll just set this to 1200 generic units, okay? And save this. And now rerun our application. And you can see that the print me method for our truck will now print out the make and the towing capacity. So we have successfully overridden the default implementation of print me in the car, and we specialized our version of car by adding a new property called towing capacity. All right, suppose that our requirements change for the car and we need to add a new property called trunk capacity as integer. All right, so this makes perfect sense for a car because most cars have a trunk. However, trucks don't have trunks. Typically, they have a bed. And so what makes sense for a car no longer makes sense for a truck. And so in these cases, the best thing that you can do is just back up a little bit and create a special type of class called an abstract base class. An abstract base class merely defines a general set of properties and methods, but it doesn't provide any implementation. You can't actually create an instance of an abstract base class. It's just there kind of as a template, all right? And so the difference between a regular base class, like we're using here with car, and an abstract base class is that you cannot create an instance of an abstract base class. The only way that it becomes useful is when there's a concrete version of the class created. And this is exactly how the stream class that we looked at a few moments ago actually works. Stream is just a concept. You can have a file stream, for example. That's something concrete. You can have a zipped file stream, but stream by itself is just a notion, an idea. It's an abstract base class. You have to actually use one of its derived classes. So in the example that we've been using up to now, we might choose to create a more generic class called vehicle. We'll use that as an abstract base class. And then we'll have both car and truck and even motorcycle inherit from it. So let's do that right now. So the first thing that I'm going to do is right click and select add class. And we're going to call this vehicle. Click OK or add. All right, the first thing that I want to do is use the must inherit keyword, which says that this is an abstract class. You have to inherit from it. Don't expect it to be able to be used on its own. So now if we were to go, for example, and try to create a new all right, and you can see the first sign that something is awry is that we get this little smart tag that says new cannot be used on a class that's declared with must inherit. Why not? Because you can't create a new instance of vehicle. All right, so let's comment that out. And let's continue working on defining it. We're going to pull, let's say, all of these properties. So I'm going to copy them here, and I'll just code this. I'll just select the comment out button. I'm going to put all of these inside a vehicle. Furthermore, I'm going to create public must override sub print me. And notice that I'm not going to create a body for this method. Why not? Because this method will never be called directly because you can't create an instance of vehicle. Rather, what it's doing is saying in order to inherit from vehicle, you have to implement a print me method. All right? So now let's go back and we're going to change this to inherits vehicle. And you can see it gives me an error here. And it says that basically I have to use overrides here. Okay, so we have successfully converted car to inheriting from the abstract base class vehicle. Let's give truck the same treatment. Now for truck, the transition's a little easier because we were already inheriting from car. The only other change that I would probably make here is, as you can see, if we go back to the module1.vb, some method is looking for a type of car, and we're passing it a type of truck, and therefore it gives us this conversion error. What we need to do now is change this from bival car as car to vehicle, and we'll even change this as well to indicate the difference in our thought process here. All right, and now we should be able to rerun our application and get back to a normal state. And we can. Great. All right, so that is the notion of an abstract base class. The antithesis, the opposite of the abstract base class, is the sealed class, meaning that you cannot inherit from it. So you might never want another class to be able to inherit from your class, so you can mark it as not inheritable. So say, for example, we create a truck class and we do not want anybody to be able to inherit from it. We can mark it as not inheritable. So, and if we were to just go below this and try to create really big truck inherits truck, we're going to get a little error that says it cannot inherit from class truck because truck is declared non-inheritable. It's sealed. You can never make another version of it. Again, you might not really understand why you would ever need to do this yourself, but this notion is used within the .NET framework. So just be aware that some classes can be inherited from or derived from, and some cannot because they've been marked not inheritable or sealed. And so here are the main takeaways from this lesson. Whenever you work with the classes in the .NET Framework class library, be aware that almost every class is part of an inheritance hierarchy. If a class has a method or properties which are not readily apparent, it might be because it's inheriting the method or the properties from a base class or an abstract base class. Now, you might learn a lot about a given feature of the framework class library if you simply stop, take a moment, and understand a little bit more about that particular class's parents or its siblings or its children that may inherit from it. So you can utilize inheritance in your own projects, but frankly, again, that might be a little down the road for you if this is indeed your first attempt at learning to program, regardless of the programming language. However, perhaps you'll work on a large project in the future where it makes sense to create some library of business rules and logic that can be applied and shared across the entire application or family of software applications within the business. In those cases, you'll undoubtedly be in need of a good inheritance strategy. And again, there are good design patterns for properly utilizing these in your application. But for now, your focus will probably be on consuming and utilizing libraries that were created by others, like the .NET Framework class library. The other takeaway from this is that there are a number of Visual Basic classes and method modifiers that the creators of the Framework class library have used in an effort to guide you when using their classes. And by that I mean that they create abstract base classes or seal classes or use other modifiers in an effort to help nudge you, the consumer and the user of those classes. It forces you to use them the way that they were originally intended. It's just a matter of realizing, oh, I can't create an instance of this class because it's marked as shared. Or, oh, I can't derive from this class because it's marked non-inheritable. So once you understand a few of those key terms, you'll be able to interpret the MSDN help and understand what you're supposed to do with a given class or what your options are when looking at the framework class library. Okay, so the next lesson, we're going to finally discuss the purpose of namespaces and look at how we can reference code that is encapsulated in other assemblies. We'll see you in that video. Thank you.